Guys, my heart is beating fast. I think something is wrong. Attendance देखने क्या किया? Marks देख लियो.
First time you guys have given correct answer.
Hello everyone. Today we are presenting our project on ECG heartbeat signal amplification using operational amplifiers. Now, normally when people hear the word ECG, they immediately think of hospitals, doctors, and dramatic movie scenes where someone shouts clear before shocking the patient, right? Thankfully, our project is much less dangerous than that. Our project focuses on detecting and amplifying tiny electrical signals generated by the human heart. The only problem is that these ECG signals are extremely weak, usually in the millivolt range. That means that the signal is so small that even minor noise from body movement, nearby electronics, or power lines can distort it. So, a circuit performs three important functions: amplification, filtering, and noise reduction. The first stage of our circuit is instrumental amplifier built using AD620 IC. This amplifier increases the weak ECG signal while rejecting common unwanted noise. In simple terms, it listens carefully to the heartbeat while ignoring unnecessary disturbances. Kind of like you're trying to hear your friend in a noisy classroom. After this, the signal passes through active filter circuits made using operational amplifiers, resistors, and capacitors. These filters remove high frequency noise and improve the waveform quality. The signal is then amplified again so that the ECG waveform becomes stronger and easier to observe to the oscilloscope. We also included a right leg drive feedback circuit, which helps reduce 50 Hz power line interference and improves signal stability. Finally, this ECG waveform is displayed on the oscilloscope for analysis. Now, let's move on to the simulation part of our project.
Before building the actual hardware, we first tested the complete circuit using Proteus Design Suite simulation software. This helped us verify the circuit safely before connecting real components, because debugging in simulation is much easier than debugging after accidentally creating smoke. In the simulation, we tested each stage one by one. First, we checked whether the instrumentation amplifier correctly amplified the weak ECG signal. Then we analyzed the filter stages to confirm that unwanted noise and DC components were removed effectively. Using the oscilloscope inside the software, we observed the waveform at different stages of the circuit. We also adjusted resistor and capacitor values to improve the gain and filter response. This process helped us understand how even small component changes can affect the entire signal quality. After optimization, the final waveform appeared much cleaner and more stable. This confirmed that our circuit design was working correctly before hardware implementation. Now let's move to the practical implementation and final results.
So after the successful simulation, we implemented the complete ECG amplification system on breadboards using operational amplifiers, resistors, capacitors, and power supply connections. One of the biggest challenges we faced was noise sensitivity. Since ECG signals are extremely weak, even loose wires or improper grounding could affect the output waveform. At one point, the oscilloscope showed more noise than heartbeat, which was slightly concerning. So careful wiring, proper grounding, and stable power connections are very important. After completing the setup, we verified the output using the oscilloscope. The practical waveform was closely matched the simulated waveform, confirming successful amplification and filtering of the ECG signal. Systems like this are widely used in biomedical instruments, patient monitoring systems, and wearable healthcare devices. Through this project, we learned important concepts such as differential amplification, active filtering, signal conditioning, and noise reduction techniques. Most importantly, we understood how electronics can be applied in real healthcare technology to monitor something as important as a human heartbeat. Thank you everyone for listening. We hope you enjoyed our presentation. Like, share, and subscribe to our channel.